All right, you guys, we're going to jump into 3.3, analyzing graphs of quadratic functions. So first thing, we're going to make sure we understand what the vertex form of a quadratic is. So the equation for vertex form, y equals a times x minus h squared plus k. H and k are going to be the x and y values of your vertex. So we can quickly pull out the vertex as an ordered pair as h comma k. So whatever your h and your k value are, just pull those out, and that's your starting point for your vertex. So in example number 1, we have a function. It is in vertex form. So if we want to know what the vertex is, we're looking at this h value and this k value. The h value in the equation is minus h, so you're always going to pull it out as the opposite of whatever it looks like. So the vertex on this equation is going to be -3, -6. The k value is exactly the way it looks. The axis of symmetry, actually, I'm going to plot that point. So let's go to -3, -6, and put a dot right there. Got a little bit off, but right at -3, -6. That's going to be your vertex. At your vertex, everything is symmetric on both sides. So the axis of symmetry is going to run through your vertex. I'm going to put a dotted line on this graph to show you that axis of symmetry. That's what splits it exactly in the middle. It's always going to be x equals, because it's a vertical line and it's the x value of your vertex. So x equals -3 is your axis of symmetry. The max or the min. So when we look at this equation, the a value is +2. So this is going to be a parabola opening up. So it's going to have a minimum value. So we have a minimum value at -6 when x is -3. All right, so let's go ahead and plot a few more points. If you go ahead and you could make a table of values if you want to. You can plug in points, but I'm just going to go ahead and put a few over here. At -1, if you plug that in, you're going to get back a y value of +2. Again, that's symmetric, so I can put it on the other side as well. That's the only points that are going to fit on my graph, so we'll go ahead and connect this happy parabola opening up. So the interval where this is increasing, remember we're only looking at x values for increasing and decreasing, so this is going to increase from -3 to +infinity. He's going to decrease from -infinity up to -3. And then the range, we're talking about the y values. The smallest y value he's going to have is -6 all the way up to +infinity. So when you're in vertex form, pretty easy to grab out that vertex and then fill in the rest. Let's go ahead and look at when we are in standard form. So friendly reminder, standard form is going to be ax squared plus bx plus c. When we're in standard form, you can find the vertex. The x value is going to be -b divided by 2a. The y value, whatever that number is that you just got when you took -b divided by 2a, plug that back into your original equation, and whatever you get out is the y value. So that's going to look like, plug it into your function f of -b divided by 2a. Sorry, this board is getting a little uncalibrated, so it's getting a little messy. All right, so -b divided by 2a, that's going to tell you the x value. Then plug in that x value into your function and you will find the y value. When you're using a graphing calculator to find your vertex, if the vertex is opening up, so if we have a happy parabola, then you're going to calculate the minimum value. If your parabola is opening down, you have a sad parabola, then you're going to calculate the maximum value, and that will just tell you what your vertex is by doing that on your graphing calculator. All right. So second example, last example I'm going to do with you guys is a quadratic in standard form. So when I look at this, my a value is -1, my b value is -2, and my c value is +4. Just taking out those numbers that are in front of x squared to x and your constant. So to find that vertex, we're going to use that formula -b divided by 2a. That's going to tell me the x value. So -b divided by 2a is going to look like -2 divided by 2 times negative 1. That's going to simplify to positive 2 divided by negative 2, which would give me back a negative 1. So I know for this vertex, the x value of the vertex is negative 1. Now plug that number back into your original equation and find the y value. So if I plug in negative 1, I'll do that over here off to the side. If I plug negative 1 in, I'm going to get negative 1 squared minus 2 times negative 1 plus 4. Simplifying that, negative 1 squared gives me a positive 1, but there's a negative in front, so I've got negative 1 plus 2 plus 4. That will simplify to positive 5. So the y value of that vertex is 5. Go ahead and plot that point on your graph. So at negative 1, positive 5, oh, big fat dot right there. The axis of symmetry always travels through that vertex, so dotted line traveling through. It's a vertical line. That's going to be x equals, and it's the number of the x portion of your vertex, so x equals negative 1. The a value is negative here, so I know this parabola is going to open down. If he's opening down, he's going to have a maximum value. The maximum value is at the y portion of your vertex, so there's a maximum at 5 when x is negative 1. If we go ahead and plot some points for this, if we plug in 0, we're going to get out a positive 4. I can mirror that on the other side. If I plug in 1 for the x value, I'll get out a positive 1. So I can plot that, mirror it on the other side. And I'll just go ahead and connect this going down. So this is increasing. When we're talking about increasing or decreasing, only talking about the x values. So he's increasing from negative infinity to negative 1. Then he's going to decrease from negative 1 to positive infinity. The range is talking about the y values. The smallest y value he's going to have is negative infinity. The largest y value is going to travel up to positive 5, including that value. All right, the rest of the notes we will talk about in class when I see you next. Thank you for watching.